Hello everyone, this is the remaining part of the previous video. So there was some problem of sound in the previous video, otherwise I would have completed this question in that video only. So let's start again. So I'm re-recording it. So the thing is, I have two functions fx and gx. For actually this question is they have deliberately made the paragraph question, and it's not made so perfectly, I must tell, because they have combined two questions together. So they know actually in paragraph type of questions, generally what happened, then the information what they give, the information is connected to each other. But for A part, we have to use this information up to here. And for B part, I have to use another information. So basically, there are two questions which are disconnected to each other for this paragraph. Anyway, let's try to solve this. So the question is, I have for the function fx, this information is given: fx, f dash x, f double x are continuous on 0 to log 2. And also f0 is 0, f dash 0 is 3, and f dash log 2 is 4, and f log 2 is 6. Moreover, we have this thing 0 to log 2 e to the power minus 2x fx dx is equal to 3. And connected to that, in this question they are asking that the value of 0 to log 2 e to the power minus 2x f double dash x dx equals to what? So of course, whatever result will come after integrating this thing, for each result or for each expression what we find in the integral of it, they have given the data for it. When you plug 0 and log 2 and of course everything, they have already given. And also this integration value they have also given. So the one way is to do it by just integrating by parts, by assuming e to the power minus 2x as the first function and f double dash x as the second function, because we have to decrease the derivative, means f double dash x is the second derivative of the function. So when we integrate back, then only we get the f dash x and the fx back in this whole progression. So for that, we don't have to take e to the power minus 2x as the second function. Usually we take by applying the Eilert rule. We don't have to do like this. We have to instead take e to the power minus 2 as the first function and integrate it. But can we think better in other way? So let's try in this way. Without integrating also we can find it out. So let us try this. So I have this part A, and I have to evaluate 0 to ln 2 e to the power minus 2x f double dash x dx. Now can I actually find it out? What if can find it out? Suppose I want to write e to the power minus 2x f double dash x, and anyhow I managed to find the simpler version of this expression so that I can apply the integration 0 to log 2 in each of the part, and that integration will be easy without any such messy calculation, and that will be actually a real achievement for us. So let's try to build it and let's think logically. The idea is that how do I get by any chance this thing in the derivative of something? So I must get this thing when I differentiate e to the power minus 2x into f dash x. I am not saying that when you differentiate this thing you get only this part, but you get one part of this. How we can get it? Let's try to differentiate this thing, and I'm just taking this derivative in the box so that I will use it later. So this is going to this derivative. Derivative is what? E to the power minus 2x into f double dash x, and plus f, not plus actually, minus, because this minus 2 will also come there. So if you're expert in differentiating, you know that what I mean to say. F dash x and then 2 times f dash x into e the power minus 2x back, because we are keeping f dash x and differentiating e the power minus 2x, so that will become minus 2 e the power minus 2x. Now try to understand this thing, that if I'm getting e the power minus 2x into f double dash x as, see that this thing I'm getting as this minus this. So suppose I have to write this thing, I can write this and plus this. Or you can think like this, that since I need only this part, I have to add this extra to get this cancel back and I will get this thing. So I can add here in derivative of this thing as 2f dash x into e the power minus 2x. But now notice, suppose I want to find the integral, I apply the integral here. So just visualize it, the consequence. This is no problem, I have to find it out. This has no problem because the derivative of this is there and I can find the integration, this function will come. But again there is a messy thing I have excuse me, f dash x into e the power minus 2x. So can I also use the same technique to get it into the cleaner version, to reduce this f dash x, means to remove this f dash x? And how this idea came to mind, okay, because you notice this information is given, means our target is to just achieve e the power minus 2x fx anyhow. Further from here, then I can directly apply the integration, and instead of just integrating I can use this fact as 3. So let's try how we can do it. So now notice again that I'm taking this part, so this is over already, so I'm taking this part, twice of f dash x e the power minus 2x, and I'm writing the derivative of 2 times fx into e the power minus 2x. So if I differentiate this thing, what I get? Twice of fx into e the power minus 2x into minus 2, because I differentiated e the power minus 2x first, and then plus twice of e the power minus 2x into f dash x. Now notice this thing, since I have to find out this part, so basically what I did, it is not equal, by the way, this is also not equal, by the way, no, this is equal, we have differentiated it. This I'm just connecting this part with this part, I'm trying to connect it. So I need this part, so I got this thing here. Let's try this thing I have, correct? So this thing is going to be this plus this, isn't it? It means at the place of this value I'm going to substitute two things together. What are those two things? Let me just box it. This part, I mean the derivative of this, and this thing. So of course this will become this and plus this, because this will go this side, so this will become plus. I hope you understood. So this e to the power minus 2x f double dash x is d by dx e to the power minus 2x into f dash x plus this thing there. So this will give you d by dx of 2fx into e to the power minus 2x, and then plus this guy. So 2 to the 4, so 4fx e to the power minus 2x. I hope you understood all these things. We are actually reversing the process. This is reverse engineering of the integration by parts over there. So it's a little bit logical, or it actually what we call exercise your mind to think on that. So what we can do here now, I can collect, now see here, I can collect this d by dx and d by dx with e to the power minus 2x, e to the power minus 2x together. What I mean to say, that I can write d by dx e to the power minus 2x into f dash x plus 2fx and plus 4 times fx e to the power minus 2x. Now you notice that it's a cool thing that this already we have achieved what we were aiming for. So here e to the power minus 2x f dash x I already have. Now I'm going to apply the integral from 0 to log 2 there because I need this thing, if you remember. So this is one thing. And I must say that if you want to actually get the feel, if you are just what we call following the entire solution, try to stop somewhere in the middle after getting the hint, and please try it for the rest of the steps. So here what we can do here, that is here what we can do here, okay, 2 times here, so 0 log 2, 0 to log 2, and again 0 to log 2. Alright, so you notice I had to evaluate this part, so of course dx I have to attach, this thing I have to achieve, but now it's a cleaner integration because this is the integration of d by dx of this derivative of this. So of course I get this function here only e to the power minus 2x f dash x plus 2fx, and it is from 0 to log 2, and this is already, you notice that the 4 is out, and 0 to log 2 fx into e to the power minus 2x dx, and this integral is already given to us as 3. So now we have all that we have to evaluate this value. So let's do it, complete it. So what we get it here at log 2 is e to the power minus 2 log 2, then f dash log 2 plus 2f log 2. This is the upper limit value, minus lower limit value is going to be 0. So that will give you 1 here as the first e to the power 0, and this is nothing but f dash 0 plus 2f0. This is the second part, second limit with the lower limit, and here this whole value is given as 3. If you can see in the question, is already given 3. So I can just write 4 into 3. And now we will evaluate this thing. So this is going to give us what? This minus 2 will jump off there on the powers, it will become e log 4. So it will be e to the power log 1 by 4, that is 1 by 4. F dash log 2 is given to us as 4. So it is 4 plus 2 times, and f log 2 is given to us as 6. So 2 times 6, and minus f dash 0 is going to be 3, and that f0 is 0. So this part is 0 already, so then no need of it, and that is going to be 3. I think this is okay, this is only for this, okay, and plus 12. Let's see. And also I do some silly mistakes in calculation of such thing, so please take care of this. So this is going to be what? 12 plus 4, 16 by 4 is 4, minus 3 plus 12, so that is going to be 13. So what I'm getting, the answer for this first part is 13. Now let's do the second part of this question, and for the second part what I'm going to do, I am collecting this information from here as a separate question. So this I taking the screenshot, let me scroll it down first. All right, so I have this second part, and for related to that, what I have to do, we have to do this thing. Okay, so of course I paste it here, and there we go. Okay, so in this question what they're asking is also, this is the second part, this is the paragraph, but in paragraph they are given 2 questions. Gx be a continuous function satisfying 0 to 1 gx 4x square minus gx dx 4 by 5, and then this whole thing is given g1 by 2 g1 by 2 square. So we can guess that something fishy is there, like it is going to give us some geometric progression or any such kind of thing. So we have to identify what the gx is there, so that this entire integration will come out to be 4 by 5. So let's try to think in this way, because they know such other information about gx, so we have to think smartly so that we can identify gx. Either you can guess, suppose you want to guess that what function I will substitute for gx, so that I can subtract it from 4x square and also multiply the result with gx again back and integrate it, it should get 4 by 5. But it's very difficult. So let's try to do this way, 0 to 1, and I'm going to multiply this entirely inside. So that is going to be gx into 4x squared minus g square x. G square x means I'm just writing in a fancy way, but the meaning of g square x is gx whole square, and that is dx. Now what we can do for here, can we are we getting the idea that this is something like 0 to 1, and if I take the minus sign out, I may get some kind of perfect square, or I can create or construct some kind of perfect square. How? If I take this minus sign out, I will get here as a square, and I have to think this as of 2ab. So 2 I'm taking out, then a is gx and b is nothing but 2x squared. So when I identify this 2x square as b, I have to add and subtract. You know the rule. So 2x square whole square, and to compensate it I'm subtracting inside only, so I'll give you 4x to the power 4, and after this will become dx. Now since I'm collecting the this thing, what I'm collecting the perfect square for the 3 terms. So this is going to be gx minus, what is that, 2x squared the whole square, and when we take this minus sign here, if you see, and append or multiply with it, what we get, plus 0 to 1 4x to the power 4 dx. Alright, so this integration is not so bad. We have done this kind of thing many times. So what we get the integration here, 0 to 1 gx minus 2x squared the whole square dx, and this is going to be 4 times and x to the power 5 by 5. So you can see there x to the power 5 by 5 from 0 to 1 will become 1 by 5, so it will become 4 by 5. And you notice that the right hand side of this whole integrand or integral is given 4 by 5. So this is, I compare with 4 by 5, so this will cancel, and so we can compare this with 0. So this is going to be 0 because this is cancel. It means the area of gx minus 2x square the whole square from 0 to 1 you found as 0. And how this area is 0 when, or integral is 0, when this function is itself 0. So 0 minus 2x squared the whole square must be 0, and so we got gx is equal to 2x square. And after that, I don't think any of a student who is preparing for J Advanced cannot do it, because this is gx is equal to 2x square, so we have to put g half, then g 1 by 2 square, g 1 by 2 to the power 10 and up to 2 to the power 10 and so on. So this we use it, and after that we have to write the this entire sum, the value of m plus if the arithmetic mean of this they're asking. So arithmetic mean means we add them up and then divide by the number of total terms, that is 10. So of course the summation we have to find of for this geometric series, and I don't think after that anyone can not do it. So I'm just leaving this up to the students and they can do it. Okay, now let's go to this question. this question is from complex number, and there is a property of an equilateral triangle. If an equilateral triangle is given here, this is Z1, Z2, Z3, and here this property, or this Z1 square, Z2 square, Z3 square is equal to Z1, Z2, Z2, Z3, Z3, Z1 is possible only if the triangle is equilateral. So if this is given, then this triangle must be equilateral. If this triangle is equilateral, the Z1 minus Z2 mod and Z2 minus Z3 mod and Z3 minus Z1 mod must be equal, because already Z1 minus Z2 mod is given to root 3, because they are the sides of the equilateral triangle. Now what they are asking, that the mod Z1 square plus mod Z2 square. So how we can use this thing? They have also given that the mod of Z1 plus Z2 plus Z3 is 21. So whenever in complex number we have a good practice of those kind of things, whenever we have the mod of something given, we square it and apply the Z into Z conjugate. So what we do, what we have is Z1 plus Z2 plus Z3 mod, and I can take the square of it, 441, and I can just write there Z1 plus Z2 plus Z3, or you can directly apply the A plus B plus C formula also with bit care. Z1 bar, Z2 bar and Z3 bar is equal to 441. So what will happen when I multiply them? So Z1 bar is mod Z1 square, again Z1 Z2 bar. So just let me write first all mod Z1 square, mod Z2 square, mod Z3 square, and you notice Z1 Z3 bar will come here. Then Z1 Z3 bar will come. Then if you take with Z, and Z1 Z2 bar will also come, because there is no such hope. After that Z2 Z1 bar, then it will come Z2 Z3 bar, then Z3 Z1 bar and Z3 Z2 bar. So this is given as 441, and in this, you notice that in the second part of the question they are asking exactly this thing. So why not we can find the second part if we can. So let's try how. So let's call this thing as equation number 1 I have. Now notice one more thing I have, that this thing here, Z1 minus Z2 mod is 2 root 3, Z2 minus Z3 mod is 2 root 3, and this is also 2 root 3. So let's use this fact. So I can write here Z1 minus Z2 mod whole square is going to be 2 to the 4th is 12. So this is going to lead to this one, mod Z1 square minus, so not minus, plus mod Z2 square minus 2, not 2 actually, what I'm doing, Z1 Z2 bar plus Z2 Z1 bar, and that is going to be 12. In the same way, can we not write for everything because they are equal? So I can write there mod Z1 square plus mod Z2 square minus, this time Z2 Z3 I mean, Z1 Z3 bar plus Z3 Z1 bar is again 12. And one more time, keep patience, mod Z2 square mod Z3 square minus Z1 Z2 Z3 bar plus Z3 Z1 bar, that is 12. So you now feel that what is going to happen, because when I add them up, this will give something interesting. What we get? If I add them up, what will happen? You notice that 2 times everything will come. So 2 times mod z1 square, mod z2 square, mod z3 square, and this is going to be minus of, let's say this sum is some quantity. Let's say this is sum, a weird sum s. So I can write this s here, and that is going to be 36. So this mod z1 square plus mod z2 square, mod z2 square, mod z3 z3 square is going to be 36 plus s by 2. I have to find s value first because it is actually convenient for us. So let's substitute this whole thing at the place of this quantity. So we are going to substitute it. So what we get it here, 36 plus s by 2 plus s is equal to 441. And from there we are going to get 36 plus 3s is equal to 882. Oh really? So 3s is equal to 882 minus 36. So s is equal to 882 minus 36 by 3. I'm very bad at calculation, this kind of thing. So let's calculate it. How much get? 12 minus 6, 6. Then 4. It's not 4. This is going to be 7 minus 3, 4. Or 4. And this is going to be 8. So 846 by 3. So this will also cancel by 3. So let's calculate it. So 3 to the 6. Then 8 and then 2. 282. Really? So I'm getting 282 for this. Now I have to find out mod z2 square plus mod z3 square is equal to what? So you already have, you notice that this s value in it we already found. Are you getting? This guy I have already found. What was that? 282. So in this equation I can substitute this as 282 and it is equal to 441. And the mod z1 is already given. I have mod z1 square. I can write it as 27. And this is mod z2 square plus mod z3 square. So this guy I have to find it out. Of course, a simple subtraction. So you can do it. So these are the 2 questions. Actually 4 questions I selected for one video, but something happened in between. Alright, so I'm receiving too many questions from different parts of India, and of course due to the scarcity of time I cannot take all the questions. It was just one random video on which I gave the email ID and the WhatsApp, and it continued for every video, and I'm receiving enormous amount of questions. So of course I'm alone. There's no team at all. I'm just revealing maybe the first time that there's no team. I am working person and I am the only person that who is doing everything, the recording, editing and everything. So sometimes I cannot take all the questions you have sent to me. I love to take all of them, but it's not the matter of any such kind of arrogance. It's just a matter of time. But I try to cover all the questions before the advanced examination. From many students I received many good responses, and that I like the most, that they are thinking in a different way also sometimes, and they're also pointing out some mistakes I did sometimes in some questions. So that is most appreciated. And I also admire the students who are doing self-study. So keep on watching and pointing out the mistakes, and don't hesitate to comment. Stay math active.